Hello class, and welcome to another class with Professor Choi. Today we're going to be learning how to do measures of central tendency and measures of spread of data. This is usually one of those sort of like beginning chapters in Intro to Statistics class or something of that sort. Alright, first thing we need to explain is that every time you collect a data set, there are two basic measures that a lot of us like to basically use in order to figure out where's the center of the data and where's the spread of the data. Okay, now for our mean deviation formula, we got to do summation absolute value x minus x bar divided by n. That's our formula for mean deviation. Alright, we also have a formula for variance that has a piece of that behavior and then it kind of goes on in a sort of different tangent at some point. So the formula for variance, if you're doing population, is summation x minus mu square over n, and then the formula for standard deviation for population is sigma equals summation, forgot the square root, so square root summation x minus mu square over n. Sorry, that's capital N because it's population. Okay? So this is my formula for standard deviation for population. This is my formula for variance for population. And this is my formula for mean deviation. Let's just start with mean deviation for now. Okay? Alright. Now, as I mentioned before, if we were doing sample, our mean will be called x bar. So when we're doing our mean deviation now, let's just assume that this is going to be our x bar for now. And again, that's just because this is the sample that we have, so it's easier to just do it with that. Alright, now let's kind of follow this formula, see where it leads us. So, we got to do x minus x bar. Every time you're solving these formulas, it's better to kind of start on the inside at the top and then move your way out and then go into the denominator. So, we're going to do that. The first thing we need to do is we got to have a list of our x's. Our x's are just these numbers. I like to list them because it keeps things easy. And you can follow my steps when you're doing that. Alright, next number is 86. Next number is 90. And 98. Oh wow, I just realized something, by the way. I don't know if you noticed that, but we need to go back and recalculate our range because we got it wrong. Our highest number in that data set is 98. And we're doing this on the fly. This is good. Alright, by the way, so notice that we were calculating our range before. We had to do the highest value minus the lowest value in our data set. So our range is the highest value minus the lowest value in our data set. The highest value is 98 and the lowest value is 65. So when we do 98 minus 65, we get 33. And there you go. That's our actual range. I just noticed right now. Well, this is what happens when you do things on the fly. Alright, so let's work on the next one. So the next point when we're doing our mean deviation now is we got to do x minus x bar. The x bar is the one that we already calculated here. That's our mean, 80.33. Okay? So we got to do x minus x bar. So we got to take each one of our x's and we're going to subtract the x bar that we have here, which is 80.33. So we're going to go 65 minus 80.33. That gives us negative 15.33. This one's going to be the same. Alright, then we got to do 78 minus 8.33. 80.33. Alright, then we got to do 86 minus 80.33. Then we got to do 90 minus 80.33. Then we got to do 98 minus 80.33. Alright, now what we have here is basically this calculation here in the formula. Alright, it says s minus x bar, so we took each one of our x's and we subtracted our x bar, which is our mean. Alright, once we have these, the next portion of the formula says absolute value. So we're going to do absolute value x minus x bar. Alright, now the absolute value, remember, of any number is basically the positive of that number. So the absolute value is the distance between 0 and whatever that number is on the number line, right or left. So therefore, the absolute value is the positive of any value, because it's kind of like the distance between 0 and where that number is. So if it's a negative number, we're just going to turn it into a positive number. And if it's a positive number, we're just going to keep it. Alright? And that's going to be our absolute value there. The next portion of the formula says you got to do summation of that. Summation. Summation basically is adding up all of those. I like to just put the summation down here because all I'm doing is I'm adding those. So I got to add them. Alright, I got 66. Alright. By the way, let me double check. Alright, 66. There you go. Alright, so that 66 is the solution for the numerator on our mean deviation. So this is 66. Now we got to take that number and divide it by our n, and our n is 6 because we have 6 pieces of data. And 66 divided by 6 is 11. Okay? So we got our mean deviation equal to 11. Alright, hope you're following me so far. Again, the mean deviation is a metric of the spread of the data. We got 11. The next one that we're going to do right now is the variance. Alright, if you're watching this video again, we're about to move to the variance. So we did our mean deviation. We're doing population variance. Alright, again, let's look at the formula for our population variance. Formula for population variance is sigma square equals summation x minus mu square over n. Alright, notice by the way that these formulas are a little complicated, so we want to go step by step, really nice and slow. So let's do that. All right, notice that our mu is basically the same as our x bar, because remember the example that we have was population, so we don't have to do much for some of those. I'm going to rewrite it just for the purpose of making sure that everybody's following what we're doing. All right, so right now we're going to take the same data set and we're going to find our population variance. Okay, now for our population variance we need to follow this formula that says it's going to be summation of x minus mu squared over n. I like to write everything down nice and slow so when you're following me you don't get too lost. So these are our x's, that's the data set that we have, and we now have to subtract our mu. So we got to do x minus mu. Now remember the mu was this number that we have here. Okay, so we got to do this minus that. So you got to take your calculator and for each one of these you got to subtract 80.33. Okay, so 15.33, 15.33. Again, I'm doing it again for redundancy purposes, so people understand where I got the numbers. All right, so 5.67, 9.67, and 17.67. All right, so in following the formula, we're doing x minus mu. That's what this is right here. Now the next step on the formula says do x minus mu squared. So we're going to take these and we're going to square them. Now remember, every time you square a negative number, it turns into a positive number because you're multiplying negative 15.33 times negative 15.33. So we got 235.009. Alright, one of the things that I always recommend my students, by the way, at this point, is you start carrying a lot of decimal spots. It's usually better to carry at least 3 or 4 decimal spots. So you know what, let me carry an extra decimal spot. Let's do 4. I know it's going to be a little tedious, but this is going to be really good because when you're doing homework problems, usually on online homework places or something like that, the program may be very, very specific. And if you put the decimal spot just a little bit lower, a little bit higher, you may get it wrong. But in reality, you did the whole math correctly. It's just that the program wants specific answer with a specific decimal spot and you don't have it. So the more decimal spots you carry on a lot of these, the better it is for you, because at the end, the answer, when you round it, you get the right answer. All right, so let's carry 4 decimal spots, even though it takes more time to do. All right, so now we're going to do this number again, square, x minus mu square, which is this number squared. All right, then we got to do 2.33 squared, or negative 2.33 squared. Okay, then we got to do 5.67 squared. Then we got to do 9.67 squared. And then we got to do 17.67 squared. Again, I'm carrying a lot of decimal spots here, and it's just to make sure that we get our numbers right when we're going to put it on our calculator, on our program online later, with all the decimal spots. Okay, so we did x minus mu squared. You get it there, about x minus mu squared. Then we're going to add, that's the next point on the formula, it says summation. So what I like to do is I just put the summation down here, and then now we got to add all of those numbers. All right, now bear with me on this one, because it could be a while. All right, I did all that, got 913.3334. All right, now that 913.3334, it's the number that goes at the top, or in the numerator in this formula. So we got 913.3334. Now we got to take that number and divide it by n. And n, remember, is 6. That's how many points we got in our data set. So that number divided by 6 is 152.22. So our variance is 152.22. Alright? That's what we got right now for our variance. Okay, hope you're following. Alright, so we got our variance of 152.22 for our data set. Now, let's work on our standard deviation. Now here's the good news about the standard deviation. If you look at the formula for standard deviation, it's basically summation square root, it's a sigma equals square root of x minus mu square over n. So what that's basically saying is that your standard deviation is your square root of your variance. So all you got to do is you take your variance and you square root it in order to get your standard deviation. So we're just going to take the answer that we got over here, our 152.22, and we find the square root of that. So our standard deviation is equal to square root of 152.22. And we got 12.3378. And that's our standard deviation. 12.3378. I want to thank you for watching another video with Professor Choi. I hope you learned something new. Remember, if you like my video, please like it at the bottom and also subscribe. Have a good one!